Good morning, everyone. Welcome to Sanvi e-learning services. This is your physical science class. Yes. Yes. In the last class, we started 6th chapter. Is matter pure? So we learn what are atoms and what are molecules. Yes. We are started the compounds. Okay. Yes. Wait a minute. Yes. So we know air around us is a mixture of gases. Yes, like nitrogen, oxygen, carbon dioxide. Yes, neon, argon. Yes, so many gases are there in the air. So here, the nitrogen. Already I explained this nitrogen and oxygen are the molecules. And here this carbon dioxide, methane, yes, carbon monoxide. All these are also molecules. But this water vapor, okay, so this H2O and CH4, CO2, CO, these are not pure compounds. Okay, these are molecules but not pure compounds. Then what we call them? So see here, water. So one drop of water consists of millions of tiny particles in that. Yes, so when we observe closely, we can see millions of water molecules in one drop of water. So the formula of water is H2O. Here always the ratio is fixed. Okay, always the ratio is fixed. H2O, that means 2 hydrogen atoms, 1 oxygen atom. Okay, every time the formula is fixed. So here we can call this as a compound. And this is also pure substance here. H2O is also pure substance. We learned that similar atoms or in an element, similar atoms or in a molecule, similar atoms will be present means we can call that as a pure substance. So here what I am saying, this H2O is also pure substance because here the ratio is fixed and they combine chemically here. Okay, a compound is a pure substance composed of 2 or more elements combined chemically in a fixed ratio. Always the ratio is fixed for this water molecule H2O. Not only H2O. For example, if you are take CO2, yes, CH4, CO, HCl, NH3. For all these molecules, the ratio is fixed. Always the ratio is fixed. Yes, so these compounds also pure substances. Excuse me. So, what are the characteristics of compound? Yes, see here. This is a big element here. Sorry, big molecule now. In this, we have so many water molecules. Yes, in this compound, we have so many water molecules here. So the properties of all these water molecules is same because you can see here the structure is same. Okay, the structure is same in each and every molecule here. So when we dividing it, see what will happen here. Yes. When we dividing it, it becomes like this. So yes, here this small water molecule, okay, this one of the small water molecule have similar properties with this biggest compound here. Yes, so here the properties are same and the ratio is fixed. Okay, the ratio is fixed and the properties are same. So we can call this also here compound. That is the smallest compound of water molecule. Okay, yes. Okay, so here this is the same compound, just smaller. The properties are same. You can see here all are the water molecules. Here also water molecules. Here also water molecules. Here also water molecule. This small compound is also molecule. Same compound, just smaller. The properties are same. There is no change in the properties. And similarly, when we have a single water molecule, when we add further water molecules to this, so it becomes a big compound now. Yes, so this big compound, okay, this big compound is also pure substance here. Why this is pure substance? Because it is homogeneous, has one kind of particles in this. It has one kind of particles, right? So here, see, a compound contains atoms of two or more elements combined chemically. So here in this, each and every molecule have similar properties with the remaining molecules in the compound. So here this is also pure substance. When we combine similar molecules together, when we divide the similar molecules from the big compound, that is also pure substances. So here the water is one of the pure substance because the ratio is always fixed. We cannot divide this into simpler substances by physical processes. Okay, here these elements are combined chemically. So these are homogeneous and it has only one kind of particles. Okay. Yes. So here a compound contains atoms of two or more elements combined chemically. So can we separate the water molecule by simpler substances with the help of physical process? So when we break the water, can we divide the water into hydrogen and oxygen? Is it possible to break the water into simpler substances? No. Yes, we cannot separate the water into its simpler substances by physical processes. So when we want to divide the water into its simpler substances, it is possible only through chemical methods. So water, here H2O, by applying chemical methods, is separated into hydrogen and oxygen. Okay, H2 and O2. H2 plus O2. So here, separation of a compound into its constituent elements is possible only by chemical methods. Not only water molecule here. Okay, any compound you can take, that compounds can be separated through into its constituent elements by chemical methods only. Yes. So here, can the components of a compound be separated by physical methods? No. Because here we can see the best example is a water. We cannot separate this water into simpler substances by physical methods. By applying chemical methods only, we can separate the components of a compound into its simpler substances. Now see, we have one single atom. See here, we have iron atoms and sulfur atoms. Okay, so we are heating these iron atoms and sulfur atoms. So what will happen here? See here, when these are heated, these iron atoms and sulfur atoms are combined together. See, each iron atom is combined with each sulfur atom. Now, when these atoms are combined together, can we separate them by physical process? Yes, see. So, when combine them, so this is a structure now. Here, we cannot separate the iron atom from this, or we cannot separate the sulfur atom from this, because here these atoms are combined by chemical process, not by physical process. Okay, these elements are combined here by chemical process. So that's why we cannot separate here the iron atoms or sulfur atoms. Now see, similarly, now we have oxygen molecule and hydrogen molecule. So by applying chemical methods, okay, when we heat them, what will happen here? This hydrogen and oxygen will combine together. See here, all hydrogen atoms and oxygen atoms are combined together. See, 2 hydrogen atoms and 1 oxygen atom is combined together here. So, we cannot separate this hydrogen or oxygen from one molecule. Okay, from this molecule, we cannot separate the hydrogen or we cannot separate the oxygen by physical process. This is a structure of water molecule. So, we cannot separate this by physical processes. Through chemical process only, we can separate the hydrogen and oxygen from the water. Yes. See here, sodium. To understand more here, so I'm giving one more example. So here, sodium. This is one of the very soft metal. We can cut the sodium with the help of knife, right? See here, when sodium is combined with chlorine gas, the solid form of sodium, when combined with the gaseous form of chlorine, it will form sodium chloride. That is a solid. Yes, sodium chloride. That is a common salt which we'll use in a home. Yes, so here the composition is fixed here, sodium chloride. So once this sodium and chlorine combine together, we cannot separate the sodium and chlorine from that salt, sodium chloride. Yes, is it possible to separate the sodium and chlorine from the sodium chloride? No, we cannot separate the sodium and chlorine from the sodium chloride. So this is also one of the pure substance here. Yes, why we are discussing about all these means here to understand about pure substances in elements and compounds here. Okay, so this sodium chloride is also one of the compound because here two different atoms are combined together chemically. And we cannot separate them by physical methods. We can separate this sodium chloride into sodium and chlorine by chemical process only. So this is also here one of the pure substance. So the properties of compounds are different from those of the elements of which they are made. That means here, see, the properties of compounds are different from those of the elements of which they are made. Because, see here, sodium and chlorine. We combine the sodium and chlorine. Here, sodium is a solid form and chlorine is a gaseous form. Finally, we got the product sodium chloride that is in the solid form. Here the properties of solid, that means sodium chloride, is different from these two. Okay, we prepare this sodium chloride from sodium and chlorine. Okay, here the properties of this reactant and product is completely different. Because here the sodium is in solid form and chlorine is in gaseous form. Finally, we got here sodium chloride is in the solid form. So the properties of this sodium, chlorine and sodium chloride completely different. Not only in this sodium chloride, in this water also. The properties of this water, this hydrogen and oxygen gas. Here also the properties are different. Okay, so here water is in the liquid form, hydrogen is in the gaseous form, and oxygen also in the gaseous form. So the properties are completely different. Okay, the products and reactants have different properties. Not only in single this water compound, sodium chloride, whatever the compound you take, in that the properties of the reactant and product are completely different. See here. So these compounds are homogeneous and have molecules of only one kind. Always, for example, we will take any example here. CO2, NH3, SCH4, HCl. Whatever the compound you take, all the compounds are homogeneous. Okay, homogeneous, pure substances have molecules of only one kind. Okay, always the ratio is fixed. Here molecules of only one kind means, for example, here CH4 is there, methane. So always the formula of methane is CH4 only, one carbon atom, 4 hydrogen atoms. So the ratio is fixed. Hydrochloric acid. Hydrochloric acid means HCl, always one hydrogen, one chlorine. Ammonia means one nitrogen, 3 hydrogen atoms. Here the ratio is always fixed. So that's why these are homogeneous and have only one molecules. One kind of particles will be present. So we can call compounds or the pure substances. Okay. Yes. So see here, we have two different types of atoms here. So one is a red color atom, one is a green color atom. So when we combine them, see here, in this we have atoms of element. This is the atom of element because all similar atoms are there in that. This is the atom of an element because in this also similar atoms are there, and this is the molecule of element, and this is also molecule of an element because similar atoms are combined together, so we can call this as a molecule. So these are the same atoms now because this is a molecule of an element. This is also molecule of an element. All these are the pure, okay, pure substances because only one kind of particles are there in this. If The atoms are combined like this. Yes, so in this we have different atoms here. One red color atom, one green color atom is combined together. This is not a element. Okay, this is not element. This is known as compound. Okay, this is also pure substance. This is a compound. Now see, what are the pure substances means? Pure substances are yes, wait.
Madam, your voice is not audible, madam.
Sorry, sir. Yes.
It's okay, ma'am, now.
Yes. Look at here. Pure substances are two types, elements and compounds. So we know elements means only one kind of particles will be present. So when we observe closely, see here, in this we can see all the same atoms will be present. Okay, there is no different atoms will be present. So when we call one substance is an element means when it consists of only one kind of atoms, that is known as element. If different atoms are there means that is not an element. Okay, remember this point. Now come to the compounds. So here we are taken one drop of water. So already I explained one drop of water consists of millions of tiny particles of number of water molecules. You can see. So here this is also one of the pure substance because always the ratio is fixed in this. Always two hydrogen atoms and one oxygen atom. Okay. So if you take salt, sugar, water, all these are compounds and they are homogeneous and have particles of one kind. Here same composition throughout. Here also same composition throughout. Here also same composition throughout. Yes. So here these are homogeneous and have particles of one kind. So we can call that substances are pure substances. So here pure substances are homogeneous, has particles of one kind and has definite set of properties. Okay, here always the properties are fixed. Now see here, this is the tea and this is one of the orange juice. To prepare tea, what we need? Tea, that means tea powder or tea leaves, milk, sugar and water, right? Some amount of water. Here in this tea powder, milk, sugar and water are mixed in different proportions. Okay, the ratio is not fixed to prepare the tea. Sometimes we may take more amount of milk or more amount of sugar or tea powder or water. Always the ratio is not fixed to prepare the tea and always will not prepare the 1 cup of tea. Sometimes we may prepare more cups of tea, right? So here to prepare tea, the ratio is not fixed, even though it is a homogeneous. Why it is homogeneous? Here you can see orange juice. So what are the ingredients in this orange pulp? Yes, water and sometimes we may add some amount of sugar. Yes, so here also the composition is same throughout the solution. So these two are appear same here. Your tea is the same composition throughout. We cannot separate the sugar from this tea. We cannot separate the milk from this. We cannot separate the water. We cannot separate the tea leaves from. Yes, from this also we cannot separate the orange pulp, water or sugar. Yes, so that's why we can call this as a homogeneous. And here have particles of more than one kind. Okay, in this more than one kind of particles will be present. The ratio is not fixed. See here, when we observe the 1 drop of tea or 1 drop of orange juice, the particles, the ratio, see, you can here see the ratio is not fixed. Okay, sometimes we may take more amount of tea powder or milk or water or sugar, so that's why the ratio is not fixed. So that's why we'll not observe the same composition in this 1 drop of tea. Similarly, in this also 1 drop of orange juice, here also the ratio is not fixed because here these components contains particles of more than one kind. Okay, so these are homogeneous. Why homogeneous? Here the composition is same throughout the solution. We cannot separate the particles from this by the filtration process, right? So here these are homogeneous and have more than one kind of particles. Then what we call these type of substances? These are not elements. Okay, these are not elements and not compounds. Okay, not elements and compounds. Then what? Yes, we'll see now. Once look at this. Here these are the heterogeneous compounds. Okay, so these are the heterogeneous compounds. Here in this beaker we have water and sand. In this water and oil, noodle soup and choco chip ice cream. Yes, all these are here heterogeneous compounds. Why heterogeneous means? Why we are calling heterogeneous means? Heterogeneous means here when we are able to make out the different proportions. Okay, here we have different proportions of the substances. Yes, and we can separate them very easily. We can separate this water and sand through filtration process. And here also we can separate the oil and water. Here also we can separate noodles and soup. Here also we can separate the choco chips from the ice cream. Yes, so here we can see the different layers here. We are observing the sand and water. We are observing the oil and water in that. And here also choco chips and ice cream. And here also noodles and soup. Yes, we are observing very clearly. And we can separate them physical process very easily. Yes. So that's why we call these substances as the heterogeneous substances. Okay. So these are the heterogeneous substances. Heterogeneous mixture is a mixture. This is also one of the mixture here. It is a made up of different substances or the same substances in different states which are not uniformly distributed in it. Okay, which are not uniformly distributed in it. Okay, so these are the impure substances or mixtures that tea or orange juice or this noodle soup, choco chip ice cream, water and sand in water, yes, oil and water, all these are impure substances or we can call mixtures. Okay, mixtures or impure substances. So these are two types, homogeneous or heterogeneous. In this, two or more kinds of particles will be present. So take the example for homogeneity and take a heterogeneous for oil in water. Yes, in this tea, we have more than one kind of particle in this. Yes, in oil and water also we have more than one kind of particle here. And they mixed in any proportion. The ratio is not fixed here to prepare tea or to mix the oil and water. The ratio is not fixed. We can mix them in any proportion. And constituents retain their properties. Here, constituents retain their properties means here, for example, if you have taken oil in water, yes, in this oil in water, we can separate the oil from the water. Yes, we can separate oil and water very easily. After separating, oil retains its properties again. Water retains its properties again. Okay. After separating of this oil and water, again oil has its a sticky nature. Yes, water has its boiling point, melting point. The properties are again retains. Right? So that's why the substances retains their properties. So here matter is of two types, pure and impure. So here we are taken in pure example gold, water. In impure we are taken tea and sand in water as the example. So what all these? See here. So matter is divided into two types now, pure substances, impure substances. In pure substances again classified into two types, elements, compounds. Impure substances again two types, homogeneous mixtures, heterogeneous mixtures. Now once see here pure substances. Here pure substances are elements and compounds and these are always homogeneous. Always homogeneous and has only one kind of particles. Okay, always one kind of particles will be present. So here we have a complex. Is this homogeneous or heterogeneous? So to prepare this complex, we need nuts, cornflakes, milk, right? Some dry fruits. So here we mix all these in different proportions. Will not take in a fixed proportions to prepare this complex, right? So this is a heterogeneous. Okay, this is not homogeneous. This is heterogeneous because the ratio is not fixed to prepare this. And here this Amul pure ghee. What does it mean here? Pure ghee means what? In this only one kind of particles will be present. Is this contains only one kind of particles in this? No. In this, there is no one kind of particles will be present. In this, different kinds of particles will be present. Yes, then why we call this as a pure ghee means here, it is not containing any harmful substances. Okay, in this more than one kind of particles will be present. It is a mixture. But why here it is pure ghee means it is not containing any harmful substances. Okay, it is not containing harmful substances in this. Right. So see here, come to impure substances, mixtures. These are two types, homogeneous and heterogeneous. So we know tea is a homogeneous mixture because the composition is same throughout the solution. Right? Here the particles are uniformly distributed in this. So when we observe tea, we cannot separate the tea leaves or sugar or water or milk from this tea. So that's why this is the homogeneous mixture. Mixture, not element, not compound. This is a mixture. And here this is salad. Salad, oil in water, sand in water. Yes, all these are heterogeneous mixtures. Yes, we can separate them by physical process. Yes, now we can separate all these vegetables here, right? Or fruits. So this is a heterogeneous substances. So all these are heterogeneous substances. So why one question here? Is pure water a mixture? Yes, is pure water is a mixture? No. Pure water is not a mixture. Okay? Because here water is consist of H2O. That means 2 hydrogen atoms and 1 oxygen atom. Here always the ratio is fixed in this. Okay? We can separate this water by chemical process only, not by physical process. This is not a mixture. That is a compound. So mixtures are, remember this point here, mixtures are formed when 2 or more substances exist together without any chemical force acting between them. Okay, mixtures are formed when 2 or more substances exist together without any chemical force acting between them. We can add them by physical process and we can divide them by physical process. There is no need of any chemical processes. Okay, so components of a mixture can be separated using physical methods. See here, for example, here iron and sulfur atoms are there. To mix them, we are using fan here. Okay, when we switch on the fan will rotate. Now the atoms also rotated here. So the positions are changed. The iron atoms are, sulfur atoms are. Now we can separate them very easily. Okay, because now these atoms are combined by physical process. There is no chemical process. So we can separate them again into its position by physical process only. So components of mixture can be separated using physical methods. Yes, so here we may have in different components here. Okay, the solid and liquid, liquid and liquid, gas and liquid. Yes, so we may have in different proportions. See here the main differences between mixtures and compounds. So mixtures are here 2 or more elements are compounds, not chemically combined. Okay, compounds here 2 or more elements combined chemically. So here take example as a tea or oil in water. Okay, here take the example of water. Now here, particles of more than one kind. Okay, in mixtures, particles of more than one kind will be present, but in compounds, particles of only one kind will be present. Okay, mixtures are homogeneous or heterogeneous, but compounds are always homogeneous. Okay, and mixtures are, here components can be separated by physical methods. Here compounds of components can be separated by chemical methods, not by physical methods. Okay, these are the properties of compounds and mixtures. Okay, so in this we have some activities based on this, so we'll complete that in the next class. Okay, thank you all of you.
Good morning, students. How are you all? Can you hear my voice? Okay, students. Welcome to Sanvi Learning Services. So today we are going to discuss about lines and angles. Okay, chapter 4, lines and angles. Okay. So in previous class, we have discussed lines and angles, type of angles. Okay, what are the vertically opposite angles and what are the corresponding angles, alternate interior angles, alternate exterior angles, interior angles on the same side of the transversal, exterior angles on the same side of the transversal. Okay, and also we have started exercise 4.3, and in this exercise 4.3, we have completed some problems also. Okay, children. So this is exercise 4.3. So all of you open exercise 4.3. And so how many problems are completed in exercise 4.3? 2 problems are completed, no? In exercise 4.3, we have completed 2 problems in previous class. Okay, children. Now, see the third problem. Okay. See, before starting the exercise, third problem. So first of all, we have to revise once again the types of angles. Okay. So first of all, vertically opposite angles. Vertically opposite angles are equal. Corresponding angles are equal. Alternate interior angles are equal. Alternate exterior angles are equal. Okay. So interior angles on the same side of the transversal are supplementary. Exterior angles on the same side of the transversal, their sum is equal to 180 degrees. It means they are supplementary. Okay. So these angles we have discussed in previous class, right, children? So now exercise 4.3, third question. Okay. Now see the third question. In the adjacent figure, AB parallel CD. Okay. So here given AB parallel CD. The line AB is parallel to CD, isn't it? AB line and CD line both are parallel lines. Why? Because they are not intersecting. And EF is perpendicular to CD, right? EF is perpendicular to CD. Why? Because see EF, see this line EF is perpendicular to CD. Why? Because here 90 degrees angle is there now. So 90 degrees angle is there means, so this line EF is perpendicular to CD. Okay. So what is asking here? Find angle AGE. Find the angle AGE. AGE, it means this angle. Okay, this angle is asking. And angle GEF, it means asking angle GEF. This angle is asking. And angle FGE. Okay. So angle FGE, it means this angle. Okay, these three angles are asking. See, angle AGE means, so what is the middle alphabet? Their angle we get. So here middle alphabet G is there. So the angle will come at G. So angle AGE, it means this angle. Angle GEF, here middle alphabet E is there. So the angle will come at E. So angle GEF, it means this angle. And angle FGE, here middle alphabet G is there. So the angle will come at G. It means angle FGE, it means this angle. Okay. These three angles we have to find out. Okay, children. So to find that three angles, now let us see. First of all, draw the figure. Exercise 4.3. Okay, exercise 4.3. So first of all, we have to draw the figure. See, the figure is given, the line, this is the line AB, and this is the line CD. CD, these two lines are parallel to each other. Okay, and this line EF, this line EF, it is perpendicular to CD. So perpendicular means it is equal to 90 degrees. And this is G. Okay. So this is the given figure, children. So in this figure, so given, right? First of all, given. So what is given? AB parallel CD, and this is parallel symbol. EF perpendicular to CD. This is perpendicular symbol. Okay, AB parallel CD and EF perpendicular CD, right? And next, what is given? Angle GED. Angle GED is equal to given 126 degrees. So angle GED means this angle. Angle GED, it means this. So this total angle. Okay, this angle is equal to 126 degrees. This total angle is GED. Okay. So now what angles we have to find out? We have to find the angles. Angle AGE. Angle AGE. This angle we have to find, and angle GEF we have to find out. Angle GEF and angle FGE and angle FGE. These three angles we have to find out. Okay, children. So this is the given question. So these three angles we have to find out. Now observe carefully. So once observe this angle GED. What is given? Angle GED. Angle GED. Okay. So when we observe this angle GED, this angle GED, otherwise You take angle GEF, it means this angle. Okay. So once you take this angle GEF. Okay. So if we observe this angle GEF is equal to, it means this angle, only this angle we are taking. So this angle we write as angle GED minus angle FED. Angle FED. Okay. It means angle GEF. It means this angle. So when we take this angle, so this angle, when we take this angle GED, total angle minus angle GED means this is total angle. Okay. Angle GED is the total angle from here to here. From this total angle, we are subtracting angle FED. This angle we are subtracting. Okay. So when we subtract that angle GED given already 126 degrees minus angle FED. See, angle FED 90 degrees angle given now here. So 90 degrees angle. 90 degrees. So how much we get angle GEF? Angle GEF is equal to 126 minus 90. How much? 126 minus 90 is equal to 30 degrees. Okay. 30 degrees. Sorry, 36 degrees. -36 we get. Okay. Angle GEF value we have got 36 degrees. Okay. One angle we have got. So which angle we have got? Angle GEF. This angle we have got. Okay. Now, once you observe the triangle GEF. Okay. In triangle GEF, the triangle name is GEF. Okay. So now take the angle in triangle GEF. In triangle GEF, here use angle sum property. What is angle sum property? What is angle sum property? Sum of three angles. Sum of three angles in a triangle is equal to 180 degrees. Okay. According to angle sum property. Okay. Angle sum property. ASP means angle sum property. So what is angle sum property? Sum of the three angles in a triangle is equal to 180 degrees. Okay. So therefore, here what are the three angles in this triangle? Once you observe the triangles, what angles we get? See, in this triangle, angle GEF, this angle, EFG, this angle, FGE, this angle. These are the three angles. Okay. So write the three angles. First of all, GEF, therefore, angle GEF plus next angle EFG, angle EFG plus angle FGE, angle FGE. Okay, that is equal to 180 degrees. These are the three angles. So sum of these three angles is equal to 180 degrees. Okay. Angle GEF, just now we have got 36 degrees. Okay. Angle GEF we have got 36 degrees. Just now we have got. Next angle EFG. Okay. What is angle EFG? What is the angle EFG? Once observe the figure. See, angle EFG, it means this angle. Okay. See, FED is equal to 90 degrees, no? So this angle also will get 90 degrees. Why? Because this angle and this angle both are alternate interior angles. Okay. So here also we get 90 degrees. So EFG also we get 90 degrees, right? So EFG is equal to 90 degrees plus FGE we don't know. Angle FGE that we don't know. That is equal to 180 degrees. Here 36 plus 90, how much? 126 degrees plus angle FGE is equal to 180 degrees. Okay. So we need angle FGE. So this plus 126 send this side. So angle FGE is equal to 180 minus 126. Okay. So angle FGE is equal to 180 minus 126. 180 minus 126 is equal to how much we get? 54 degrees. Okay. One more angle we have got. Angle FGE. Okay. So angle FGE means which angle? Angle FGE. This angle we have got. First we found angle GEF. Next we have got angle FGE. Next what angle we needed? Angle AGE. Angle AGE we needed. Okay. So once observe angle AGE, what angle it is? See angle AGE. Angle AGE. It means this angle. Okay, this angle we have to find out. So to find this angle, see this is the exterior angle of this triangle now. Okay, this angle AGE is the exterior angle of this triangle. So here exterior angle property we have to apply. So exterior angle AGE is equal to sum of its opposite interior angles. It means GEF plus EFG. This angle, sum of its opposite interior angles are this angle. It means GEF, and this angle. It means angle EFG. Okay. So apply here exterior angle property. Angle AGE is equal to angle AGE is equal to angle GEF angle GEF plus EFG angle EFG. Okay. So angle GEF we have got 36 degrees plus angle EFG is equal to 90 degrees. So how much total? 126 degrees. What angle it is? Angle AGE. Okay. So now we have got three angles. So which angles are asked? So we have got three angles. So these problems will get some confusion, children, but we should understand carefully. Okay. If you understand properly, they are very easy. Okay, children. Now let us see the next problem. The next question is given. So once observe the next problem, what is given here. Fourth problem. See, in the adjacent figure, PQ parallel ST. See here, the arrow mark line. This PQ is parallel to ST. It means PQ line and ST line both are parallel to each other. Angle PQR is equal to 110 degrees given. Angle PQR, it means the angle will come at Q. Why? Because middle alphabet Q is there. So angle PQR is equal to given 110 degrees. And angle RST is equal to given 130 degrees. Okay. RST, it means this angle. So what is asking here? Find angle QRS. Angle QRS, it means this angle is asking. Okay, angle QRS. So this angle we have to find out. And here one hint is given. Draw a line parallel to ST through point R. Draw a line parallel to ST through the point R. So through this point R, we have to draw a line parallel to ST. This is the ST line. So we have to draw the line parallel to this line ST. Okay, we have drawn the line parallel to ST. Okay. So to find angle QRS, so this is the given a small hint. So that is draw a line parallel to ST. Okay. So this is the problem. Now to solve this, so first of all draw the figure. Now see the figure is given. So this is the given figure, children. P, Q, R, S, T. Okay. And here PQ are given 110 degrees angle. Angle 110 degrees given. And here the angle RST given 130 degrees. Okay. So again what he is saying, draw a line parallel to ST through the point R. Okay. So he is saying that draw a line parallel to ST through the point R. Okay. This is the line parallel to ST. So this is the line parallel to ST. Suppose this line name is L. Okay, this line we have drawn. So when we draw this line parallel to ST, okay, so here we got three angles. One angle is this one, and this angle, and this angle. Three angles we have got here. Suppose this is angle A, this is angle B, and this is angle C. We have got three angles here. Okay. So actually what is asking here? Angle QRS. It means angle B we have to find out. Okay. So now write the solution. Given, this is the fourth problem. Given so what is given in this problem? PQ parallel ST given. PQ is parallel to ST given. Okay. And again what he said, draw a line. Draw a line. Draw a line L. Draw a line L. Parallel to ST. Through the point R. through the point R. Here PQ parallel ST given and angle PQR given. Angle PQR is equal to 110 degrees given and angle RST is equal to 130 degrees given. So this is the given information in the question. So again what he said, draw a line L parallel to ST through the point R. Okay, we drew the line L parallel to ST through the point R. So here we have got three angles when we draw a line parallel to ST. So now observe the figure. From the figure, let's observe the figure. A plus 110 is equal to 180 degrees. A plus 110 is equal to 180 degrees and C plus 130 degrees is equal to 180 degrees. See, we have written like this from this figure. So what we have written, A plus 110 is equal to 180 degrees we have written. In the same way, C plus 130 is equal to we written 180 degrees. Why their sum is equal to 180 degrees means, once observe angle A and angle 110. See, these are the interior angles on the same side of the transversal. See here, PQ and L are the parallel lines. For these two parallel lines, QR is the transversal. Okay, QR is the transversal. So, if we observe this angle A and angle 110, these are the interior angles and they are same side of the transversal. So, we all know that interior angles on the same side of the transversal, their sum is equal to 180 degrees. So, A plus 110 degrees is equal to 180 degrees. In the same way, angle C and 130 degrees also same interior angles on the same side of the transversal. Why? Because here ST and the line L are parallel to each other and SR is the transversal. So C and 130 degrees are the interior angles and they are same side of the transversal. That's why their sum is equal to 180 degrees. That's why here we have written A plus 110 is equal to 180 degrees and C plus 130 is equal to 180 degrees. So why? Because the reason is interior angles on the same side of the transversal. Why? Because the two angles are interior angles on the same side of the transversal. Okay. So, therefore, here plus 110 bring this side. Plus 110 becomes minus 110. And here also this plus 130 bring this side. C is equal to this plus 130 becomes minus 130. So A is equal to 180 minus 110. How much? 70 degrees. And C is equal to how much? 180 minus 130 means 50 degrees. So A is equal to we got 70 degrees and C is equal to we have got 50 degrees. Okay. So but actually what we have to find? Actually we have to find angle QRS. It means this angle. Angle B we have to find out. Okay, angle QRS means angle B we have to find. But we have got angle A and angle C. Okay, so from these two angles we can find angle B. So how means? Once observe these three angles A, B and C. These three angles are at a point on the same line, isn't it? Angles at a point on the same line. See, if we observe this angle A, B and C, these three angles are lying on the same point, at the same point and on the same line. Okay, so we know that the angles at a point on the same line, their sum is equal to 180 degrees. Okay, so angle A plus angle B plus angle C is equal to 180 degrees. So right here, and angle A plus angle B plus angle C is equal to 180 degrees. So why? Because angles at a point on a line. So already we have discussed the angles lying on the same line at a point, their sum is equal to 180 degrees. Okay, angles around the points means 360 degrees. Angles at a point means 180 degrees. Angles around the point means 360 degrees. Okay. So here now substitute the values A and C. A value is 70 degrees plus B value we don't know plus C value we have got 50 degrees. That is equal to 180 degrees. Here 70 plus 50 how much? 120 plus B is equal to 180 degrees. This plus 120 bring this side. B is equal to 180 minus 120. It means, so B is equal to 180 minus 120 how much? 60 degrees. So B is equal to 60 degrees means angle B means what? Angle QRS. So therefore angle QRS is equal to 60 degrees. Angle B is nothing but angle QRS. Okay. So angle QRS is equal to 60 degrees. So this angle which we have needed. Okay, children. So now let us see the next problem. Now see the fifth question. Fifth question is given in the adjacent figure M parallel N. Okay, here the line M is parallel to the line N. M parallel to N. A comma B, A and B are any 2 points on M and N respectively. So here A and B are any 2 points on these two lines M and N. Let C be an interior. Here the point C is an interior point between the lines M and N. So between the lines M and N, C is the interior point. So what is asking here? Find angle ACB. Find angle ACB. Means this angle we have to find out. It means angle Z we have to find. Here he mentioned angle ACB. Angle he mentioned Z. Okay. It means this angle Z we have to find out. Right. So observe the figure carefully. Now draw the figure. Okay. Now draw the figure. So this is the line M and the line N. Okay, M and N are two lines. A and B are any 2 points. Okay, this is the point A and this is the point B. Okay, and here angle C is given, point C is given, and here the angle Z is given. Okay, so before that, to find angle ACB, so we have to draw one more line parallel to these two lines. Suppose see, I am drawing one more line. Suppose this line name is L. Okay. So when we draw these two lines here, when we draw a line L parallel to M and N, here again we got two angles. Okay, we will get two angles. Here one angle we will get, that is A, and here we get one more angle, that is B. Two angles we are getting. Okay, children? Two angles we are getting. So here point X you take, and here point you take Y. It is given already in the figure. Okay. Angle X, and this is angle Y. Right? This is the given figure, children. So now, first of all, write given. Fifth problem, given. So what is given in fifth problem? First of all, he said M parallel N. Okay. M parallel N. M parallel N he has given. So what is asking? And angle ACB. Angle ACB. This value is asking. M parallel N given and asking angle ACB. This value is asking. Okay. So to find this angle, so we drew a line L parallel to M and N. Right. That you write. Draw a line. Draw a line parallel to M and N through the point C. Okay. So we drew a line parallel to, we drew a line L parallel to M and N through the point C. Okay. And we have got two more angles, angle A and angle B. Okay. Now, once observe this figure, angle X and angle A, both are alternate interior angles. See here, for L and M, two parallel lines, angle BC is a transversal. If we observe X and A, they are corresponding, alternate interior angles. And if we observe Y and B, these two also alternate interior angles. We all know that alternate interior angles are equal to each other. Okay. So now from the figure, okay. So what angles are equal? X is equal to A and Y is equal to B. Why? Because they are alternate interior angles. Why they are equal means they are alternate interior angles. Okay. So therefore, now find angle Z. See, if we take angle Z, so where we have angle Z is given this total. This angle Z we have to find out. Angle Z is nothing but angle A plus angle B now. Okay. Angle A plus angle B. If we add angle A and angle B, we get angle Z. Okay, children. So now angle Z is equal to A plus B. Therefore, angle Z is nothing but angle ACB is equal to A plus B. A value is X we have got plus B value we got Y. It means angle ACB is equal to X plus Y. Okay, children. Now the time is up. So the remaining problems homework you do and come at home. 5 problems are completed. The rest of the problems you complete at home. So remaining problems are homework. So in this total, how many problems? 12 problems are there. In the 12 problems, 5 completed. The remaining problems homework. Okay. Thank you, children. Thank you all.